Good morning, good morning, good morning. This is a quick review on parent graphs. So I'm going to go through, look at several of these, remind you how we identify and what the parent functions are of each, and then you should be able to use this as a resource for your Spiral Review quiz. So in looking at this, this should remind you very much of the graphs that we have used for the viral growth. So this is exponential growth. And we represent exponential growth as y equals a times 2 to the x, because for the most part it's doubling in size, which is why we use this number 2. This is a straight line, so it is a linear graph. Now, linear graphs use the format y equals mx plus b. And the thing you need to keep in mind is this one has a negative x. How do I know? Because as I look at it from left to right, it is going down. So this has a negative x. So you could also use this equation as the parent graph. This one is decay. This is exponential decay. So you have to kind of think of this in terms of our zombie apocalypse activity, where the number of population is going down by about half, right? So we have about half the population each time. So the equation for this is going to be y equals a to the 1/2 to the x. And this is because we're doing half of the original data. That is how the decay is being illustrated. This next one is an inequality. Well, how do I know it's an inequality? Well, I know it's an inequality because this is shaded in. Also, I know it's an inequality because the line is dotted. So this is going to be, it uses the same equation. In fact, all of these could have been inequalities. So it uses the same equation for a line, but instead of being an equal sign, it's an inequality sign. This is absolute value. And the one piece I want you to pay attention is that everything moves into the positive direction, and that kind of makes sense. So when something is negative, the absolute value changes it to a positive. So it would make sense that everything is positive in the y direction. So this one looks a lot like a exponential graph. In fact, it is an exponential graph that's been turned on its side. And so if you think about it in terms of this, you should be able to say, okay, well, what is related to exponents? Well, we know from our history of solving them that a log or a logarithm is the inverse or the opposite of exponential. So this is actually a logarithmic graph. This one has an asymptote here. It approaches -5. It'll never get quite to -5. So this would be y equals the log of x. And continuing, with the logarithms, this just happens to be a different log. I don't know why I picked two of them, but this is yet another log graph. So y equals log of x. Okay. Let's go down to this one. This is a radical. This is a square root function. So this is the radical, or we can call it square root. So the equation, the parent function for this is y equals the square root of x. And this one, it's the square root, but then we put another one this way. So this is actually our cube root, or cubic. Let's call it the cube root, which is y equals the cube root of x. This final one we haven't talked about, but this is rational functions. This is going to be the last unit that we end up going over. But so these are rational numbers. The remaining graphs are polynomials. So I want to talk about polynomials separately. So as a reminder for graphs of polynomials, if you remember correctly, we split these into two kind of groups. We have odd degrees and we have even degrees. Remember, the degree is the exponent that is the highest. So the odd polynomials are going to be y equals x, y equals x to the third, y equals x to the fifth, y equals x to the seventh, and on and on. The evens are going to be y equals x squared, y equals x to the fourth, y equals x to the sixth, and on. Remember, for even, they are always either up, up, or down, down. And you need to remember that up, up has a positive coefficient, and down, down has a negative coefficient. So if I look through these polynomials that are remaining, this one here, this one here goes down, down. That means it is an even polynomial with a negative coefficient. This blue one here goes up, up, so it is an even with a positive coefficient. This one here goes down, down, so again, it is even, but with a negative coefficient. And then the last one we're going to look at that happens to be even. This one goes up, up, so it's going to be a positive. Now let's go back and look at this blue one here. The other one. Okay, this one is a quadratic. Why? Because it looks like a U. So the base, the parent function for this is y equals x squared. And we can add extra things, but for the most part, it's y equals x squared. I can tell that the vertex for this has moved to the left 3, and it is moved up 1. And so in adjusting my equation, I would take my parent function and I would, to the left 3 means I put it with my x and its opposite. And then I put my plus 1, and that's all I have to do. That's my equation. So if I'm looking at this negative, again, the parent function is y equals x squared. This one has a negative coefficient, so it is y equals a negative x squared. And again, we move it to the right 3 and down 1. A negative to the right 3 means it's going to be a minus 3. And down 1 is a minus 1. And I end up simplifying that otherwise, but that's an equation for this particular graph. Now, what about the other two evens? Well, this has an extra bump. So this tells me it is y times x to the 4th. Because every extra bump you add, we increase the exponent one more step. And then the last of our evens, so we have one extra bump. So again, this is y equals x to the 4th is our parent function. Now, when we're thinking about the odds, odds always have one up and one down. If it is positive, then it is going up to the right and down to the left. If it is negative, it is going down to the right and up to the left. So again, down, left, up, right, down, left, up, right, down, left, up, right, down, left, up, right, for every single one of the odds, for every single one of, that are positive. It is up, left, down, right, up, left, down, right, up, left, down, right, and up, left, down, right, if it is negative for each one of the odds. So when I look at these, this is odd because one of them's down and one of them's up. This is a down left, it's an upright, so this is going to be odd. It is going to be positive. And then we count our extra humps. This is going to be y x to the fifth. Because we have 1, 2, 3, 4 turns plus one more, that's our fifth. Okay. 1, 2, 3, 4 plus our one more, that's our fifth. That means it is, well, it's already odd, and it is y to the fifth. But it is not positive. It is negative. And why? Because it is going up to the left and down to the right. This is, there's 2 turns plus one more. That means this is going to be y x to the third. Left, right, it is a positive and it is odd. 1, 2 plus the third, it is odd. This is y equals x to the third. Up left, down right, it is negative coefficient. So remember, for all parent functions, you need to have these memorized: exponential, linear, inequality, decay, absolute value. We've just added logarithm. Polynomials, radicals, and I just added rational functions. So you need to be able to identify each one of them, and remember that no matter what the parent function is, if you put a number inside parentheses next to the x, you are moving it right or left. And these are opposites. So a positive number moves it left and a negative number moves it right. If you put a number at the end, it is moving it up or down. And if you put a number out front, it changes its shape. If it's a negative out front, you are flipping it. It's instead of being open up, it'll be open down. Instead of being down up, it'll be up down. So the negative flips it. And when I say the shape, it makes it skinnier or it makes it fatter. I hope this is helpful. I will talk to you soon.